Testing, can you hear me? Testing, can you hear me? Testing again. Okay, so this stream is public now. So I'm going to be studying introductory statistics again. I'll just study from where I left off last time. Last time I studied about confidence intervals. This time I will study whatever this topic is. I remember doing hypothesis testing in late high school, but I completely forgot what it is. By the end of this chapter, okay. Confidence interval are one way uh, are one way to estimate a population parameter. Another way to make a statistical inference to make a decision about a parameter. For example, a car dealer advertises that its new small truck gets 35 miles per gallon on average. A tutoring service claims that its method of tutoring helps 90% of its students get an A or a B. A statistician will make a decision about these claims. This process is called hypothesis testing. A hypothesis test involves collecting data from a sample and evaluating the data. Then the statistician makes a decision as to whether or not there is sufficient evidence based upon analysis of the data to reject the null hypothesis. In this chapter, you will conduct hypothesis tests on single means and single proportions. You'll also learn about errors associated with these tests. Perform a hypothesis test. A statistician will set up two contradictory hypotheses, collect sample data, determine the correct distribution to perform the hypothesis test, analyze the sample data by performing the calculations that ultimately will allow you to reject or decline to reject the null hypothesis, make a decision, and write a meaningful conclusion. The actual test begins by considering two hypotheses. They are called the null hypothesis and the alternative hypothesis. The null hypothesis is a statement of no difference between the variables. They are not related. This can often be considered the status quo, and as a result, if you cannot accept the null, it requires some action. So null is what they're claiming. Alternative hypothesis, a claim about a population that is contradictory to null hypothesis, and what we conclude when we reject null hypothesis. This is what the researcher is trying to prove. Okay, so there is the null hypothesis, right? Then the alternative hypothesis. After you have determined which hypothesis the sample supports, you make a decision. There are two options for a decision. They are reject null hypothesis if the sample information favors the alternative hypothesis, or do not reject null hypothesis, or decline to reject null hypothesis. If the sample information is insufficient to reject the null hypothesis, mathematical symbols used in null and alternative hypothesis: equal, greater than or equal to, less than or equal to, not equal, greater than, less than, more than. Okay. We want to test whether the mean GPA of the students in American colleges is different from 2.0 out of 2.5, out of 4.0. The null and alternative hypothesis are: the null hypothesis is that the average is 2. The null is what is already assumed. The alternative is that the mean is not 2. We want to test whether the mean height of 8th graders is 66 inches. State the null and alternative hypothesis. So the null hypothesis, there is no answer. Is that the mean is equal to 66, and the alternative is that the mean is not equal to 66. When you perform a hypothesis test, there are 4 possible outcomes depending on the actual truth or falseness of the null hypothesis and the decision to reject or not. The outcomes are summarized in the following table. Action and null hypothesis are actually true or false. So do not reject null hypothesis. Correct outcome, type 2 error. Okay, if the null hypothesis is true and we rejected it, then that's a type 1 error. If the null hypothesis is false and we do not reject it, that's a type 2 error. So type 2 when null hypothesis false, type 1 when null hypothesis is actually true. So type 1, probability of rejecting the null hypothesis when the null hypothesis is true. Type 2, probability of rejecting the null hypothesis when the null hypothesis is false. Alpha and beta should be as small as possible because their probabilities of error, they're rarely zero. Suppose the null hypothesis is Nava's rock climbing equipment is safe. Type 1 error: Nava thinks that her rock climbing equipment may not be safe when in fact it is really safe. Type 2 error: Nava thinks that her rock climbing equipment may be safe when in fact it is not safe. Alpha probability that Nava thinks her rock climbing equipment may not be safe when in fact it really is safe. Beta is the probability that Nava thinks her rock climbing equipment may be safe when in fact it is not safe. Probability distribution needed for hypothesis testing. Earlier in this course, we discussed sample distributions. Particular distributions are associated with the various types of hypothesis testing. Following table summarizes various hypothesis tests and the corresponding probability distributions that will be used to conduct the test. So, population parameter mu p, estimated value x bar p apostrophe. Probability distribution used: normal distribution x bar is normally distributed mu x sigma x over root n. Okay, so hypothesis test for the mean when the population standard deviation is known. We use this. Hypothesis test for the mean when the population standard deviation is unknown and the distribution of the sample mean is approximately normal. Then we use student's t distribution. Hypothesis test for proportions. Use normal distribution. Okay, I need to see some examples. When you perform a hypothesis test of a single population mean, mu, using a normal distribution, often called a z-test, you take a simple random sample from the population. Population you're testing is normally distributed and your sample size sufficiently large. You know the value of the population standard deviation, which in reality is rarely known. When you perform a hypothesis test of a single population mean, mu, using the student's t distribution, often called a t-test, there are fundamental assumptions that need to be met in order for the test to work properly. Your data should be a simple random sample that comes from a population that is approximately normally distributed. You use the sample standard deviation to approximate population standard deviation. When you perform a hypothesis test of a single population proportion P, you take a simple random sample from the population. You must meet the conditions for a binomial distribution. There are a certain number n of independent trials. The outcomes of any trial are success or failure. Each trial has the same probability of a success P. Shape of the binomial distribution needs to be similar to the shape of the normal distribution. To ensure this, the quantities NP and NQ must both be greater than 5. Then the binomial distribution of a sample proportion can be approximated by the normal distribution with mu is equal to P and sigma is equal to root PQ over N. Okay. Establishing the type of distribution, sample size, unknown or unknown, standard deviation can help you figure out how to go about a hypothesis test. However, there are several other factors you should consider when working out a hypothesis test. Suppose you make a assumption about a property of the population. This assumption is the null hypothesis. Then you gather sample data randomly if the sample has properties that would be very unlikely to occur if the assumption is true. Then you would conclude that your assumption about the population is probably incorrect. Okay. Use the sample data to calculate the actual probability of getting the test result called the p-value. P-value is the probability that if the null hypothesis is true, the results from other randomly selected sample will be an extreme or more extreme as the results obtained from the given sample. A large p-value collected from the data indicates that we should not reject the null hypothesis. So p-value is the probability that if the null hypothesis is true, the results from another randomly selected sample will be as extreme or more extreme as the results obtained from a given sample. Yeah, I don't like the wording over here. Smaller the p-value, the more unlikely the outcome. Stronger the evidence is against the null hypothesis. You should reject the null hypothesis if the evidence is strongly against it. Suppose a baker claims that his bread height is more than 15 centimeter on average. Several of his customers do not believe him. persuade his customers that he is right, the baker decides to do a hypothesis test. He bakes 10 loaves of bread. Height of the mean loaves 17 centimeters. The mean height of the sample loaves is 17. The baker knows from baking hundreds of loaves of bread that the standard deviation for the height is 0.5 centimeter and the distribution of heights is normal. The null hypothesis could be that mu is less than or equal to 15. Baker claims that his bread height is more than 15 centimeters on average. Shouldn't this be the null hypothesis? Okay, we are going by what the customers believe. The customers believe mean is less than or equal to 15, and the alternative hypothesis would be that the mean is more than 15. The words is more than translate as greater than. By the central limit theorem, the distribution of the sample means for samples of 10 loaves will be normal with mean mu is equal to 15 and standard deviation sigma over root n, which is 0.5 over root 10, is equal to 0.16. Okay, central limit theorem. The distribution of the sample means for samples of 10 loaves a normal with mean 15 and standard deviation with 0.16. Why is there 0.5 here? Okay, so the baker claims that the height is the standard deviation is 0.5. Suppose the null hypothesis is true. Then is the mean height 17 centimeters calculated from the sample unexpectedly large? The hypothesis test works by asking the question how unlikely the sample mean would be if the null hypothesis were true. Okay, so by this central limit theorem, we assume that we make a normal distribution with mean this and standard deviation 0.16 and check how far away 17 is. Also, I want to see. Also, we have to use the z-score, right? And I want to see their table. Table. The p-value then is the probability that a sample mean is the same or greater than 17 centimeters. The population mean is in fact 15 centimeters. We can calculate this probability using normal distribution for means. How many standard deviations away is the 17 from 15? 17 minus 15 is 2. And then 2 divided by 0.16. 12.5 standard deviations away. 12.5. P-value is the probability that x bar is more than 17, which is approximately 0. The p-value is the probability that if we were to take other samples, any other sample mean would fall at least as far out as 17 centimeters. Okay, the p-value is the probability that if we were to take other samples, any other sample mean would fall at least as far out as 17 centimeters. The p-value is approximately 0. 12.5 is very far right. How do I do the normal distribution? Functions, normal distribution. I think the problem with this is I can't like the z-score is 12.5. Uh, it's like this, right? P-value of approximately 0 tells us that it is highly unlikely that a loaf of bread rises no more than 15 centimeters on average. That is almost 0% of the loaves of bread would be at least as high as 17 centimeters purely by chance. Had the population mean height really been 15 centimeters? Because the outcome of the 17 centimeter because the outcome of 17 centimeter is so unlikely, we conclude that the evidence is strongly against the null hypothesis. There is sufficient evidence that the true mean height for the population of the baker's loaf of bread is greater than 15. A systematic way to make a decision about whether to reject or not reject the null hypothesis is to compare the p-value and a preset or conceived alpha, also called a significance level. A preset alpha is the probability of a type 1 error, rejecting the null hypothesis when the null hypothesis is true. It may or may not be given to you at the beginning of the problem. When you make a decision to reject or not reject null hypothesis, do as follows. Alpha is more than p, then reject the null hypothesis. What is alpha is the probability of type 1 error rejecting the null hypothesis when the null hypothesis is true. If it's more than the p-value, then we reject it. The results of the sample data are significant. There is significant evidence to conclude the null hypothesis is an incorrect belief. If alpha is less than equal to p value, do not reject null hypothesis. The results of the sample data are not significant. There is not sufficient evidence to conclude that the alternative hypothesis may be correct. When you do not reject null hypothesis, it does not mean that you should believe the null hypothesis is true. It simply means that the sample data have failed to provide sufficient evidence to cast serious doubt about the truthfulness of null hypothesis. I don't understand this part. If the probability of type 1 error is higher than p value, why are we rejecting the null hypothesis? Shouldn't it be the opposite? Okay, in our example, p value was very high. Wait, no. P value was approximately 0. But alpha was lower than p value, right? How do we calculate alpha? In using p value to evaluate a hypothesis test, sometimes useful to use the following memory device. P value low, null must go. P value low, null must go. P value high, null must fly. P value less than the established alpha as rejecting the null hypothesis. Likewise relates a p value higher than the established alpha as not rejecting the null hypothesis. Reject when the p value is less than the established alpha value. The results of the sample data do not. The results of the sample data support the alternative hypothesis. Do not reject the null hypothesis when the p-value is greater than the established alpha value. The results of the sample data do not support the alternative hypothesis. I think I should do the next chapter as well. I wanted to do some examples. In a hypothesis test problem, you may see words such as level of significance is 1%. The 1% is the preconceived or preset alpha. Okay, so 1%, the level of significance basically means the p value has to be lower than 1% in order to convince me that the null hypothesis is false. I think level of significance is like how much, what the probability should be to convince me to reject the null hypothesis, the maximum probability. The statistician setting up the null hypothesis selects the value of alpha to use before correcting the sample data. If no level of significance is given, a common standard is to use alpha as 0.05. 5%. When you calculate the p-value and draw the picture, the p-value is the area in the left tail, the right tail, or split evenly between the two tails. For this reason, we call hypothesis test left, right, or two-tailed. The alternative hypothesis tells you if the test is left, right, or two-tailed. It is the key to conducting the appropriate test. Alternative hypothesis never has a symbol that contains an equal sign. Thinking about the meaning of the p-value. Data analyst should have more confidence that he made the correct decision to reject the null hypothesis with a smaller p-value, even if using the 0.05 level of for alpha. Uh, so it's not mean is mu, alternative mu is less than 5. Test of a single population mean. Alternative hypothesis tells you that the test is left tail. Picture of the p-value is as follows. So the alternate hypothesis says that mu is less than 5. Okay. Yeah, I want to see an exercise. How do we decide the boundary for this one? Oh, wait, no, the area is 50, right? Okay, okay. Jeffrey, as an 8-year-old, established a mean time of 16.43 seconds for swimming the 25-yard freestyle, the standard deviation of zero point 0.8. His dad, Frank, thought that Jeffrey could swim a 25-yard freestyle faster using goggles. Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 25-yard freestyle swims. For 15 swims, Jeffrey's mean time was 16 seconds. Frank thought that the goggles helped Jeffrey to swim faster than the 16.43 seconds. Conduct a hypothesis test using a preset alpha is 0.05. So the p value has to be below 0.05 in order to reject the null hypothesis. Okay, so this is example 9.14. Wait. Something is wrong. Something is wrong with my tablet. I will just restart it and then I'll try to work at it again. So the null hypothesis. Wait, I will just focus on my tablet first. Okay, it's working now. So here talking example 9.41. I, I I don't know why I end up reading wrong. Like I'm reading a sentence, but in my head I'm reading something else. So the established mean time of 16.43 seconds for swimming 25-yard freestyle with a standard deviation of 0.8. So what is established is that the mean is 16.43. Standard deviation is 0.8. Right? And then we collected X, 15, 25-yard freestyle swims. So X bar was 16. N is 15. So by the central limit theorem, X bar follows a normal distribution of the mean, the original mean, which is 16.43, divided and this, right? Standard deviation divided by root 15. 0.207. 0.207. Now let's figure out the z-score. 16.43. So the difference is, so we take the difference and we divide it by this. This is equal to, so 0.43 divided by this, 2.817. 2 point what? 2.081. 2.0817. Um, 0817. The area is 0.019. Wait. 16 seconds is smaller than 16.43. Right? Mean of 1. So standard deviation. Mean is 0, standard deviation 1. I don't think it matters. It's either one tail or the other tail, right? So anyways, 2.0817, 0.019 probability that x is more than 0. Is 0.019. So I think we reject the null hypothesis then, right? Because the level of significance is 0.05, 0.0187 is the p-value. If null hypothesis is true, so because the 1.87% chance is small, the mean time of 16 seconds is less than the less 16 seconds or less is unlikely to have happened randomly. It is a rare event. Since p-value is smaller than alpha, alpha is what it takes to convince us, and p-value is smaller than that, so we reject the null hypothesis. Okay. Uh, let's do this. Example 9.15. A college football coach records the mean weight that the players can bench press as 275 pounds with standard deviation of 55 pounds. Mean weight is 275 and standard deviation is 55. Three of the players thought that the mean weight was more than the amount. More than what amount? Records the mean weight that the players can bench press as 275 pounds. Three of the players thought that the mean weight was more than the amount. Then the mean weight is actually more than 275. He asked 30 of their teammates for their estimated maximum lift on the bench press. Data range from 205 to 385. Conduct a hypothesis test using a 2.5% level of significance to determine if the bench press mean is more than 275 pounds. First, I don't want to calculate this on my own, so I will just use their value. So 2.75, n is 30. X is distributed normally with mean 275 and then 55 over 30. And then the mean we calculated, well, they calculated is 286.2 pounds. 286.2. Okay, so now what we do, so we take the difference and since the sample mean is distributed like this, we divide it by the standard deviation and we get the z-score. So 286.2 divided by 55 over 30. 1.0 0.115. Probability that x is x probability that no, it's not probability that x. Probability that the z score would be. Yep, the probability is for the z score, right? Hold on. Let me see. How do you present the normal distribution? Do you write z? Uh, Probability that z is more than equal to this. Okay, probability that by z I mean the normal distribution with the mean 0 and standard deviation 1. Probability of this is 0.132. So that if our significant if our alpha is what 2.5, p value is lesser than no, p value is not lesser. We do not reject the null hypothesis. Yeah, we do not reject it. Is not sufficient evidence to conclude that the true mean weight lifted is more than 275 pounds. Statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks the mean score is higher than 65. He samples 10 statistics students and obtains the scores. This performs a hypothesis test using a 5% level of significance. Weighs the standard deviation. So they believe the mean score on the first statistics is 65. A statistics instructor thinks the mean score is higher than 65. Do we have to use the t thing? The t distribution? The t distribution. Sample size of 20 items. Then we calculate the degrees of freedom as 19. Over here, degrees of freedom is 9, right? Degrees of freedom is 9. First statistics test is 65. Example 9.16. first statistics test. So our mu is 65. Our standard deviation is unknown. 10 students. Um, 65, 65, 70. 66, 6338. 6338. 6338. 71, 72. Yeah. 67 is the thing. So T distribution, degrees of freedom is 9. The population standard deviation is not known. The error bound for the population mean is this. This is the t-score. The area to the right equal to alpha over 2. Okay, let me see an example. Distribution of the sample mean is approximately normal. Let me try this. So how do I find this what value to plug into the t distribution? How do I find the t-score? So this is the t-score. S over root n. Okay, wait. So standard deviation. Can I find, is there a function for the standard deviation? Standard deviation. I have to do this 9 times. $3.197. They have standard deviation, they have mean. $3.19722. I'm getting 1.978. Forget this. 1.97814. Say 0.04. Here's a 5% level of significance, right? So we do reject the null hypothesis. Calculate the p-value using students' t distribution. So degrees of freedom is 9. P-value more than 67.039. The sample mean and standard deviation are calculated as 67 and 3.1972 from the data. I mean, yeah, but what do you mean? 67. Uh, did I get something wrong? Standard deviation over root 10. And 3.9. I think 3.96 is correct. Yeah. 3.964. 3.96. So we do reject it, right? June, how do you pronounce this? June believes that 50% of the first time brides in the US are younger than their grooms. She performs a hypothesis test to determine if the percentage is the same or different from 50%. June samples 100 first time brides and 53 replied that they are younger than their grooms. For the hypothesis test, she uses a 1% level of significance. For example, 9.17. So it's this one, right? Probability distribution used is this normal distribution and P probability of success root PQ over N. So P 53 out of 100. So P is 0.53. What is 1 minus 4047? And then the distribution we use. Population proportion. So 50% of the proportion. So our estimated proportion will be P apostrophe over root 100 is just 10. Um, 0.53 and square root. This is the normal distribution. 53 replied that they're younger than their um okay, let's see. Wait, what are we supposed to find out? I'm not really sure. 53, right? 53 replied that they're younger than their grooms. Let me think. So from 0.5 to 0.53, we check the area started. 0.553, 0.075. Oh no, that's not it. Do we check 0.53 and no, I don't think this is this correct? Can't remember how to do this one. The z-score is 1.96. problem contains no mention of a mean. I mean, it says 50%, right? So in the previous problem, what was the mean that they took? This is just for the confidence interval. There was no mean here. Okay, I think this 53 is wrong. I should take 50 as a given. So P is 50. Q is 50. And then the Z score. Okay, Z score is 53. Yeah, now I understand. 53 minus 50 divided by this. D divided by 50 times 50 over 10. 1.0.1897. 0.1897. Um 0.024815. So we accept the null hypothesis, right? The p value, what they calculated was 0.274. Yeah, I don't understand what they did. Um, Having it less than 0.47 or more than 0.53, 0.5485. The null hypothesis is true. There is a 0.5485 probability that the sample proportion P apostrophe is 0.53 or more or 0.47 or less. You cannot reject the null hypothesis. This one I did not understand. Let's see what's after this. It's just the last exercise. Anyways, it's been almost an hour. I will end the stream here and I'll continue the rest in the next stream. Anyways, I will see you guys later then. Bye.